Good morning, children. Today, in the chapter Periodic Classification of Elements, under the topic Trends in the Modern Periodic Table, I will teach you variation of atomic size, metallic and non-metallic character, and oxide nature of elements across the period and down to the group.
Atomic size, it may click in your mind what is the atomic size of an atom of an element and how can we determine the atomic size. So children, atomic size, it is the distance between the center of the nucleus of an atom with the valence shell. For your level, you can keep in your mind valence shell electrons. The distance between the center of the nucleus and valence shell electron, that distance also known as atomic radius. And this atomic radius measured in terms of picometer, picometer. And higher the atomic radius, bigger the atomic size. So through the atomic radius, we can determine the size of the atoms. So now let us discuss how do this atomic size change on moving across the period and down to the group. In atomic size across the period and down to the group. But before explaining about the atomic size, let me explain about the nuclear force. As already you have learned or you know very well, the atoms are made up of positively charged protons in the nucleus with neutrons. Nucleus contains protons and neutrons, and electrons are revolved around the nucleus in a fixed orbit, or we can say cell, for which the energies are fixed. So the electrons are around the nucleus, and there is a force between this proton and electrons. This force of attraction between protons and electrons, that is called as a nuclear force. The nucleus proton present in the nucleus held the electrons with some force. That force is known as nuclear force. Of atomic size in a group. Children, atomic size when we move from top to bottom in a group increases. Atomic size increases from top to bottom in a group. Let me explain this one in detail. Or we can say in other words, reason for increase in atomic size while moving from top to bottom in a group. Let us consider the group 2 elements. The elements are beryllium, magnesium, calcium. Electronic configuration beryllium 2 magnesium 282, calcium 2882. Now draw the atomic structure for all these three. Beryllium, it has 4 protons in the nucleus, 2 electrons in first cell and 2 electrons in its L shell. K shell, L shell, both 2 electrons. Come to magnesium. Magnesium, here you can see 12 protons in the nucleus. It has K shell, L shell and M shell. Magnesium has 3 shells. K shell 2 electrons, L shell 8 electrons and M shell 2 electrons. Likewise, if you go for calcium, it has 2, 3, 4. I am drawing the structure here. It has 20 protons in the nucleus and has 1, 2, K cell, L cell, M and N. It has 4 cells, K, L, M, N. 2, 8, 8, 2 electrons. Now, when you can see, as we move from beryllium to calcium, the distance between the nucleus, center of the nucleus and valence cell, it is small, that means radius is less radius. Here, the distance is more than this, and here, the distance is because it has one more extra cell added. So, on moving from top to bottom, as one extra cell added in each step, and hence the distance between the center of the nucleus and valence shell electron increases from beryllium to magnesium to calcium. That means beryllium size is smaller than magnesium, magnesium is smaller than calcium. That means on moving top to bottom, the atomic size increases. Now, let us discuss the variation of atomic size in period. That means, how do the atomic size change on moving from left to right in a period? Children, on moving from left to right in a period, the atomic size decreases. Atomic size across the period decreases. How can we explain this? For this, I have taken the second period elements. Elements of second period, whose electronic configurations are lithium 2,1, beryllium 2,2, boron 2,3, carbon 2,4, nitrogen 2,5, oxygen 2,6, fluorine 2,7, neon 2,8. Now let us draw the atomic structure. Atomic structure of lithium. It has 3 protons in the nucleus with 2 electrons in the first shell and 1 electron in second shell. This is for lithium. Now next to beryllium. Beryllium has 4 protons in the nucleus, 2 electrons in K shell or first shell and 2 electrons in its L shell for beryllium. Next, boron, 5 electrons, 5 protons in the nucleus, 2 electrons in K shell and 3 electrons in its L shell, K shell, L shell. So if you move from left to right, you can draw some more. Let us go for one more carbon. 6 protons in the nucleus, 2 electrons in K shell and 4 electrons in its L shell. Boron, carbon. So when we move from left to right, you can see the number of electrons, protons, it increases by 1 unit. At the same time, number of electrons are also increases by 1 unit. Here it is 1, 2, 3 and here 4. Just now what we had discussed? Nuclear force. The force of attraction between the protons present in the nucleus and electrons in the valence shell, or especially you can go for the valence electrons. In all the elements L shell for second period. And hence, as the number of electrons increases by 1 unit which enter into the same cell, the nuclear force. What you can think about the nuclear force? Will it increase or decrease across the period? The nuclear force increases. On moving from left to right across the period, the nuclear force increases. This increase in the nuclear force causes the valence shell electrons to come little bit more closer. And hence, the distance between the center of the nucleus and valence shell less than the previous one. That means lithium size is bigger than beryllium. Now, if there are 3 valence electrons in the same shell, then 5 protons, these 5 protons can pull these 3 electrons in the same shell move closer, and hence the distance between the center of the nucleus and this valence shell electron or valence shell is more closer as compared to beryllium. Likewise for carbon, the valence electrons are 4 in the same L shell and hence it will come more closer. Again here you can see the distance between the center of nucleus and valence shell less. So on moving from left to right, we can see the size going on decreasing. Let us move to our next property, that is metallic and non-metallic characters of elements across the period and down to the curve. What is metallic nature or metallic properties? Children, metallic property is the property due to which atom of an element can lose the electrons. When the metal atom loses electrons to form positively charged particles, this is known as its metallic character. And the more easily an atom can lose the electrons, the more metallic nature it has. How do this metallic nature change from top to bottom in a group or left to right in a period? We are going to discuss. Non-metallic character or non-metallic properties. Children, the non-metallic character just opposite to the metallic character. Here, the non-metal atoms can gain the electrons to form negatively charged particles called anion. Again here, the tendency of gaining electron by non-metal atoms, we can say it's non-metallic character. The more easily an atom gains the electron, the more non-metallic character it has. Variation of metallic character in a group. On moving from top to bottom in a group, the metallic character increases. For example, if you take the elements of group 1, lithium, sodium, potassium. On moving from top to bottom, lithium is less metallic or less reactive than sodium. Sodium is less than potassium. That means potassium is highly metallic in nature, lithium is least reactive. Now let me explain. On moving from top to bottom, atomic size increases. Increasing the atomic size, what happens to nuclear force? Nuclear force decreases. And as there is a decrease in the nuclear force, the valence electrons can be removed easily. That means the hold of the protons on the valence electron is going on decreases, and this decrease in the holes on the valence shell electrons makes the atoms to remove or to lose the electron more easily, and hence the metallic property increases from top to bottom in a group. Non-metallic character down to the group. Children, the non-metallic characters from top to bottom in a group decreases. Let me explain this through the example of group 17 elements. Elements of group number 17. The element belongs to group number 17 are fluorine, chlorine, bromine, iodine. I am taking up to this. So as what you have learned, size of the fluorine, atomic size on moving from top to bottom, atomic size increases. That means fluorine size is smaller than chlorine, chlorine smaller than bromine, bromine smaller than iodine. On moving from top to bottom, as the atomic size increases, the nuclear force, this is also decreases. Nuclear force decreases. Okay, and what is non-metallic character? It is the tendency to gain the electrons. Smaller the size, easier the atoms to gain the electron, because the proton is closer to the valence shell and can be accept the electron more easily. So that as the atomic size increases, nuclear force decreases, means the non-metallic character decreases from top to bottom. That means we can see non-metallic character fluorine is the highest non-metallic character, followed by chlorine, bromine, and then iodine. Iodine somewhat will show the few metallic character as well. Here fluorine, chlorine, bromine, all they are in the gaseous state, whereas iodine, it is a dark purple solid. And non-metallic character across the period. That means how do the metallic and non-metallic character change on moving from left to right in a period. Children, on moving from left to right in a period, its metallic character decreases, whereas non-metallic character increases. Let us take the example of third period. The elements of third period are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Already you have learned about the atomic size. How do the atomic size change on moving from left to right in a period? Atomic size, already you have learned, atomic size decreases on moving from left to right in a period. For your knowledge, just let me explain here. 17, fluorine belongs to fluorine, chlorine, bromine, halogens, they belongs to 17th group, whereas inert gases are in 18th group, argon. All the elements of 18th group, their atomic size is slightly bigger than the halogens because of stability of the inert gases. Okay. So here on this slide, inert gases, their size is bigger than the halogens. Now, as the atomic size decreases, the nuclear force will increase or decrease. The nuclear force increases. That means the atoms to get the electrons more easily. That means the tendency of gaining electron easily, whereas losing electron as the smaller size atoms can lose the electron with difficulty, whereas small size atoms can gain the electron more easily. Hence, we can say on moving from left to right, the metallic character decreases and non-metallic character increases. Oxide nature across the period. When we move from left to right in a period, the nature of basic oxide decreases, whereas non-metallic oxide nature increases. For example, if you take oxide of sodium, Na2O, that is basic in nature. Basic property, magnesium oxide, it is also basic. Aluminum oxide, Al2O3, here it is amphoteric in nature, amphoteric oxide. And what is amphoteric oxide? Already I taught you the chapter acid bases. The oxides which show the both basic oxide nature as well as acidic oxide nature are known as amphoteric. Silicon oxide is also basic in nature. Phosphorus P2O5, it is acidic. And Cl2O7. That means on moving from left to right, this is strong base, this is weak base, this is amphoteric, it is also amphoteric oxide, less acidic, and this is more acidic. That means on moving from left to right in a period, the basic strength decreases, whereas acidic property increases. Acidic property increases and basic property decreases on moving from left to right in a period.